Welcome you to the next session, lecture 9 of embedded software testing. In the previous session, we had learned the V model lifecycle, how it is, the basic elements of that. We took an V model typical elements, requirements, design, low-level design, and implementation. On par with this, we have testing staggered on the right hand side. So we will develop the tests as per the horizontal line. So for the requirements, high level test or acceptance test we will write. For the design we will write system test. For the low level units we will write integration test. For the source code we have the unit testing. And we also learned that for any embedded software development and testing, so we have a prototyping and formal life cycle. Prototyping, what we do is we will define our own prototyping iterations where we define, realize, and evaluate the various items of the entire software life cycle, and that will be iterated till it is finalized. So at the end of this prototype, we have a finalized SRS, design document, source, test case, test procedure, and a set of test result. And also we learned that for each stages of the life cycle, there has to be an entry and exit criteria. We know that the conditions that must be satisfied for entry and exit, based on that only it can move to the next stage. The formal life cycle also we studied, where we picked up a sample specification design coding on par with that testing, integration testing, and unit testing. So this looks like a V shape, that's why it is called a V life cycle. There are different models that are allowed, that are used, such as waterfall, iterative, agile, and all that. But in general, in the embedded industry, they follow V model. So that is what we learned in the session 8. And in this session, we focus on some of the processes that are followed for each of the stage. So each stage will have a process. The process elements are objective, scope, entry, inputs, outputs, and exit criteria. What are those objectives? What are those scope? So how do we define entry? What is input, output, exit, etc. So taking an example of acceptance test plan and test cases, we identify or define these main elements. For objective, we say that to prepare acceptance test plan in line with the SRS and as per the business acceptance criteria. Scope is applicable for the embedded software project. You can define a name, a project name, where acceptance testing is done from the user perspective. The scope is only for the customer or with the along with the client, something like that. We will have it in the scope. Entry criteria tells that we need a baseline software requirement specification with the help of which we will satisfy the objective, and availability of the plan. I mean, the plan will have all the tools, environment, and the schedule identified with the pointers. So that will be an entry or the entry criteria that is identified. And once we have the entry criteria, there are various inputs that are used: baseline software requirement specification, baseline the project plan. This will be the input. And what is the outcome of the acceptance test plan phase is that baseline test plan and traceability. And once it is complete, we exit out of this phase and go to the next phase. That is about an example of a one acceptance test plan creation and preparation. We will go in detail with the definition of each of this in the next slides. Okay. For example, a DVD player or a workstation, PlayStation, etc. So there, what they do is they define three levels: high level, low level, and the next is the output level or the conceptual level of exiting. So high level, what they do is they define the concept, they will gather the requirement, they will do the design. With this, they will end the high level phase, and the next level life cycle will have implementation and integration. These two combined. Once this is done, they will directly go with the V&V, that is validation and verification. They will take all these inputs right from the high level to the low level, and they do the V&V. And once the V&V is complete, the product is bug fixed, working, and can be deployable. Once it is there, they'll go for maintenance. The interesting thing is that a consumer electronics product have to be maintained well, and there is a supporting mechanism that is required from the organization towards the customer or the clients. So they will add a maintenance as one of the product phase towards the end. So this is an example of consumer electronics product life cycle. In general, for embedded software testing, entry and exit criteria, how they are used. In general, I am talking about. If you want to do a software testing defined for an embedded system, the entry should have SRS design code minimum, and they should be baseline. The entry should have a test plan, test specification signed off. That means in order to test, we cannot go without the test plan. We need to have a test plan, and the test specification identify the test cases and procedures, and they should be signed off. That means they should be approved by the test team as well as the qualifying authority or the QA team. Along with that, as per the test plan, the test setup and tools should be configured. That means they should be available for the usage, and that will be consistently used across the testing life cycle till the testing is complete. And in order to do the testing, we need to have a software build. On the software build, we will apply the testing mechanism with the help of the test setup. So these are the entry criteria for doing the software testing. As an outcome of this life cycle, what is the exit criteria? What is the exit? Test execution completion along with the test logs and measured outputs. So we say testing life cycle is complete when we have the exit of test execution completed with test logs or reports generated and any measurement that we have done as an output of this testing activity. All tests should be reported either a pass or fail. That means each test needs to have a reporting whether those tests are passed or those tests are failed. And whatever the artifacts we report should be baseline. Baseline means we will stop at a stage where we say that it is complete with the identification baseline number. We will take up what is baseline and all that when we go through the configuration management session of configuration. So in general, these entry and exit are very important. Okay. So we'll take an example of one testing life cycle. So we'll touch base on what are the elements that an automotive testing phases and process takes it to complete the testing life cycle. Go through automotive testing phases and processes. What are those? See, basically automotive testing phase is categorized into 5 phases. You can see system and requirement study, test planning, test execution and defect management, package and release, and test closure. As I said in earlier session, previous session, that software development life cycle has development as well as testing. So this is in particular talking about only the testing, that is testing life cycle. So do not get confused with the development life cycle, testing life cycle, etc. It's all part of the integral process of the embedded software testing. Sorry, embedded software system. So that has the development cycle as well as testing life cycle. Here I am looking into the testing life cycle only. Okay. So automotive testing phases and processes. So we have 5 phases: system requirement and study, test planning, test execution and defect management, package and release, test closure. This is for a typical automotive testing. For example, take a engine control unit or a telematic system or any braking control system or any vision systems, etc. as part of the automotives, specifically cars. Okay, so each one will touch base. So what do we do in system and requirement study, and what do we do in test planning, what do we do in test execution and defect management, and what do we do in package and release, and each one has its own process. System and requirement study, you see it in the arrow, there is a process defined. For test execution and defect management, that also can have automation. As told earlier, you have multiple scripts running one shot, you can automate it as a batch, and that is nothing but test automation, and that also has a process which we can apply for the test execution as part of the test execution and defect management process. Once this test execution is completed, we are going to have a release mechanism, release process. We do a package and release of the product. So that also is part of the testing phase. How we are going to do it. Finally, we end with the test closure process. How are we going to close the testing life cycle? Okay, so each one will take up. Okay, the first one is being a system and requirement study process. As I said earlier, we need to have objective, scope, entry, exit, and between entry and exit, we will identify inputs and outputs. Okay, for system and requirement study process, what are those? Objective: to gather the requirement specification for testing, to understand the user requirement for testing. I guess it is a straightforward, simpler one. So we will gather the requirements of the system under test. We will understand or analyze the requirement. So this is very important term. We need to have an thorough knowledge or system knowledge of the embedded system which is under test. Then we define the scope. So whatever the scope of the testing. So we say applicable to embedded automotive testing type product. That is whatever we do this objectives is applicable only for the particular testing of the particular product. And we have entry criteria as a next element in the process. Testing activity kickoff, project go ahead awarded by customer. That means we will enter into this phase of system and requirement study once customer says yes, go ahead with this, or if it is a internal project or the product, there is a approving authority or a go ahead authority who will say you can start. So testing activity is kicked off on that time where the entry is done. Once we have the entry, we are going to have all the inputs or the inputs that are identified. What are those inputs? It could be a customer inputs, that is a customer input specification. It could be a contract given by the customer which will identify all the input material and customer supplied material, as I said, as part of the contract, and any of the below or all of the below, whatever it is. Usually it will be a software requirement specification. It will be a design document. Here design document is something which is been as an outcome of the development phase. Functional specification, what are the functionality that this product is going to have. and any business requirements document from the customer perspective, and any user manual that customer wants or customer has given or the development team has developed, and test cases and scripts. Here is not that the test cycle, testing life cycle test cases. It is sample test cases from similar product earlier, or customer has anything to validate this product. Those things are part of this, and application prototype products equipments to be tested. That means the actual product or the actual end target system or the actual application which needs to be tested. This is a very important input for us to study. Another thing is engineering or market requirements list. That means what are the engineering requirements? It is not just enough to have a SRS. For the tester or for the developer, he needs to have an engineering element as an understanding of the product under development or test. So he needs to have a marketing item material. That means requirement. So what is that end customer is going to have it once this product is deployed into the customer or the end user. All this will be considered in terms of inputs development or identification of the inputs. The next one is outputs. Output of this activity is test strategy. That means how am I going to test it? How means it is not that practical steps, or it is not that real steps of what values I am going to use at all. Overall, I know that what system is. I have understood how the system is going to behave. What are the functionalities it has? What are the customer expected or customer expectation has in terms of the product that is going to be deployed in the market. Considering all that, how I am going to test it as a defect-free product. That strategy will produce as an output of this activity. That means it could have multiple methods or approaches identified for different functionalities or identified for different set of requirements or the prototypes or the products. All this will be laid out as a document, which is nothing but a strategy document. So that is the outcome of this system and requirement study process. We can also list out an example. Suppose some analog set of requirements or a functionality is there. How I am going to test it? What is that strategy that I will adopt for testing those features? So that all will be part of this document. So that is nothing but test strategy document. And this test strategy has to be signed off by the customer if it is customer driven or some authority who is going to approve it. For him, the test team or whoever has done the study process has to submit the strategy and he will review and approve it. So that is the exit criteria. So once again, we have objective of this system and requirement study process. We will gather the requirement, we will understand what the system is, and the scope is to test it or testing type of a product. Entry criteria will have a kickoff and go ahead from the approving authority or the customer. The inputs that are required for this study, these are all customer inputs, any material, SRS, design documents from the development team or the developed product, functional specification, business requirements, user manual, test cases, scripts, any sample scripts if they have done for doing an initial testing at the customer end or the developer end, that also can be input. And from the engineering perspective, any inputs that are required, that also will be an input. Then we have the outputs as a strategy document, and exit a sign off from the internal customer or the real customer. So that is about system requirement study process, which is nothing but the first phase of the testing life cycle. It is something like a study process. Okay, the next one. Once we study and understand the system and identify different things, what is it is going to require for conducting the testing, we are going to plan it. How I am going to do it, and how means what sort of a planning that I need to have. in order to do the testing. So the planning also again has the objective, scope, entry, input, output, exit. The objective is here prepare test plan detailing test approach, strategy, types of testing, entry and exit criteria for test execution. Prepare detailed test cases for customer requirements. That means test cases identified for customers inputs will be part of the planning. We will identify samples with details, how it looks like, what is it going to have. All this will be part of the planning process. Then we will define the scope. Again, it's for the embedded automotive testing type. How we are going to enter into this test planning process is baseline test strategy document available or approved by the customer. So you remember, test strategy is an output of the previous phase where we have done the study and understanding of the system. That will be an entry here, and that is an input as well. Test management tool, anything that we want to manage with the help of a tool, that also can be an input. And below are the multiple inputs, that is SRS, design, function specification, business requirements, user manual, test cases, and any scripts given by the customer, and application features, prototypes, equipments that are to be tested from the customer perspective. This all will go into the planning process because I need to plan what I am going to deploy, how I am going to execute. All this will be laid out as a plan, and the output of this activity will have baseline test plan and test cases signed off by customer. That means I am going to develop few samples with some details, and that should be agreed by the customer or the internal management. And we will also develop a sort of a traceability. That traceability will map into the test strategy with the requirements and how I am going to run the tests that I have laid out. Test run plan it is called. It's a small run plan that will identify the preconditions, execution mechanism, and the outputs that is expected. I guess the sample test plan we went through in one of the session. Maybe I will open up again sometime later in this session, or if time permits, or the next session. So exit criteria is approval of test management plan and test cases by customer and the stakeholders within the organization. So this is about a test planning. So we have gone through two phases of the testing life cycle. One is a system and requirement study, other one is a test planning. The next one is the most important thing, the important one, that is test execution and defect management. Okay, so this has the test execution and defect management process has objective to identify, track the defects. That means here basically we are going to execute. As a result of execution, definitely there will be some issues or defects. How those defects are going to be mitigated, or how those defects are going to be fixed, and how they are going to be tracked. All this will be part of this objective. And the scope is again for testing the automotive test product. Here entry criteria is baseline test plan. The previous cycle, usually it will be a previous cycle exit. The output will be an entry criteria here. Test cases reviewed and approved. Baseline test plan. Availability of customer supplied material. Because I need to execute on the end target. Definitely I need to have it as a target based testing system. So definitely we are going to have the required material as per the plan. The inputs that are required are identified hardware, software, tools, technical material, test cases, test data, test run plan. So all this will be required because with the help of this only I am going to execute. The outputs of this activity is updated test plan, updated traceability matrix. As I said, traceability matrix is the important aspect of the testing lifecycle because I need to trace each of the requirements, how I have tested, how I have covered in terms of what sort of a test. All this will be part of the traceability matrix. And also we come up with the test cases and scripts as an outcome of this activity of test execution and defect management. Exit criteria, we have all the defects logged and reported to the customer. It could be an internal development team also or internal management who will route all these defects to a fix by the development team, or if it is an issue with the requirements or the engineering level from customer, then customer needs to fix it. We have to log to him. There are situations where some of the tests will result in modifying the requirement, or some of the results failed will result in modifying the product to an extent such that it can be testable and deployable. And all the testing which cannot continue, like I have here I will take a typical example. I have suppose some 100 requirements to be tested. In that I have completed about 60%. That means 60 requirements I have covered. Now I found out that 50% of this requirement have resulted in bugs. Let's say it need not be 50. 50% is too high. Say 20. 20% of the tested requirements have bugs, meaning that there are 12 requirements have failed. Am I right? Yes. So 12 requirements have failed. That means these are sampling which the testing team has to consider, or based on the sampling that is defined with the test plan. As per the test plan, so we will take a call. Our testing team will take a call either to stop the test or start the test or continue the test. So these are very important aspects of testing that is called toll gate. Toll gate is nothing but a sampling criteria wherein a decision is taken whether to continue that activity or the product is enough to take up to the next level. So that is what the toll gate is. So based on the plan, this will be taken. The decision for toll gate is taken care. So that is what the exit criteria, to stop certain criteria whether it is met or not, or to continue. So that is what is about test execution and defect management process. So this is the third phase what we have seen, and as I said, test automation also could be there, where we do the execution with the help of batch execution, batch script running and all that. So automation will definitely help in hello. Yes, test automation will help in speeding the process of execution. It also helps in manual intervention and any defects that are due to manual errors can be avoided. That means more you automate, the chance of injecting human errors are less. That is why we use automation. So for the automation, we can define an automation process wherein we can have a small entry put output exit criteria for that separately. I am not told here. Maybe we can take it up as an exercise when we do the practical sessions. So that is about the third life cycle, which is nothing but test execution and defect management. Test automation and process also can be defined as part of this activity. It's a very important activity of all the testing life cycle. Okay, next is the package. Once we are done with the test execution defects, we are good to go for package and release process. So what are the things that it has? So objective is process for preparation and execution of automation test scripts, preparation process of test data for parameterization in automation tools. Oh, I'm sorry, this is not about the package and release. Further, I've already listed out the automation process as I depicted here. All this can be applied in this slide. Here what we do is execution of automation will define automation process. The objective is the preparation and execution of automation test scripts and parameterization automation tools. That means what are the parameters that will be used. Those parameters are usually test data inputs and test data outputs. All this will be fed into the automation tools. Automation tools can be done with the help of Python or any of the DOS batch execution. All this will have a test data. Test data needs to be parameterized for each of these scripts, inputs, execution. Of course, there are various automation tools with the help of NICE, LabVIEW, test and it's together they use it usually from National Instruments. Okay, that is about the test automation and tools that are used. Scope is same. Entry is a stable application environment. That means automation, once we are ready to do the automation, we should not crumble in between. That means it cannot fail. So it's difficult to find out. Once we are good to run all the tests, then we are going to have a batch execution. For that we need to have a stable environment. That means the testing environment, whatever you are going to execute, should be stable enough to take care of all this automation. Of course, the machines, networks, database, and parameters all should be set up for taking care of the test automation. Then control the test environment where no other instances or access is made during the test. That means the performance is no compromise of the test. The test environment is completely controlled with the help of this automation. And, there is no intervention in between when the execution is on. What are the inputs? Baseline test strategy. Again, test strategy can identify what is the sort of automation and test data that will be used for automation execution, and those things will be defined in the strategy document. So that is one of the input. That should be baseline. Test cases and tools, test data, customer supplied material, test environment specification. It is not just enough to have a test environment in place. It is very important to have a test environment defined with the spec, and it is called work instruction. That means a sort of a how to use the test environment, because the testing team has to be independent, and given a day, anybody having enough knowledge of the system should be able to test with the help of this defined this specification or work instructions. The output of the test automation process is test automation deliverables with test results. That means as an output of the testing with the help of automation, we will have the results. That is an outcome of this process. The exit criteria is validation and acceptance of automation test suite, acceptance of automation test pack by client. That means the output of the automation should be accepted by the relevant stakeholders. Okay, now come to packaging and releasing. Once we are done with the testing, what are the process that we follow for packaging and release of the embedded tested product. Here the objective is to ensure that the deliverable product or software packaging and release activities take place in accordance with the user requirements. That means we cannot deliver the product saying that I have tested and take it. We should have a well-defined process, well-defined packaging mechanism. Packaging doesn't mean that it is packaging with any beautiful binding or folders or something like that. It is also important to document how we are going to deliver the tested product. That's very important because that should be acceptable by the user and he should be able to pick as if he is not having any knowledge of the intricacies of the packaged or released product. He should be able to pick it up as per the well-defined instructions as per the process. So that is the objective of this process. Scope is again the testing product of the embedded system. The entry criteria is software tested completely and test results are recorded. And test results recorded means all the test results should ideally be passed. Basically, the end user expects test results are addressed. Here, mostly it is passed. For the failed ones, there should be enough justifications telling that such and such features are not tested, or I would say it's not tested. It is something like justified, saying that some features are not tested in the well-defined manner or the way it is tested, but there is enough hint saying that that defect will not occur, or saying that certain features are tested in a different mechanism. Basically, that also can be considered as passed only, but enough information should be there for the other items where it is tested indirectly or using any alternate mechanism of testing. So that is the entry criteria for packaging and releasing the product. Completed our products ready for packaging and release. The inputs for doing the packaging and releasing is all deliverables should be available. It should be baseline as per the project plan, and project plan should be baseline. That means project plan will be revisited how it is getting done in terms of packaging and releasing. Requirements document, design documents, dependent material from customer. That means whatever we have used for testing the product have to be categorized and they should be available. What is the input on a given day for releasing it? So that is same thing should be available before we release the product. Outputs. A release note should be there mentioning all the release items. What are the items that are released? So what is the configuration information for that? Any version information and any manual it is going to point to, or any work instructions how it should be used. All this, any troubleshooting information, all this will be part of this release note. I mean, release note will not have the data for all this, but it will have a pointer. It will have a information about all these things. And the packaged work product is another output. That means the output is cleanly maintained as per what is being told in the earlier process or the planning process. That means such and such folders will have such and such past results or failed results or reports will be there. And here where the build is there, all this will be part of the work product structure. That should be part of the output. And how we exit is the delivered product or the release should be successfully deployed and installed at customer side. Usually it is not just enough to send or deliver just to the customer or the end user. It should be satisfactorily working at his site, and it should be available for customer, and that's what is called as deployed successfully at the deliverable end. All the packaging and release requirements have been identified or satisfied. Successful release of software products. It means all the items that is required as per the requirement should be available at customer side satisfactorily and should be running all the time. That is what we will end up with the packaging and release process. So that is about the fourth process. Literally it is a fifth process because we have covered up the test automation process also. So we are done with this process of package and release. The next one is the last process in the testing life cycle. It is nothing but test closure. So what it has, test closure process has an objective of gather and come up with a mechanism for collecting inputs required for process improvement through project retrospection activities. What it means here, what we do is we have delivered the product, we have tested the product, and we have got a deployable product available at the customer. It is not just enough to just deliver and see that we are done. It is very important to come up with what we have done so far, the entire life cycle of development. It could be testing, or it could be a sub process, or it's automation, or any feature wise bug fix. All this have to be recorded thoroughly. So very important aspect, because we are going to live with embedded systems for multiple life cycles, or it could be a different embedded systems or a subsystem. All these lessons learned is called lessons learned, and other one term is very important, best practices. These two aspects we will record it, we will have it. That is an objective of this closure. It's called a closure activity. As part of the closure activity, we record all the aspects of what we have done in the process and how we can improve on the lessons that we have learned while implementing the testing. And we are going to archive the product what we have delivered, because it could be required anytime to revisit or to redeliver whatever it is. We need to have an archiving mechanism as per the plan. Closure of the testing activities. That means we are going to put a full stop for all these testing aspects. Scope is applicable again for the product that is intended to test, and we have all deliverables. We have entry criteria in terms of all deliverables have been delivered to the customer satisfactorily. Overall product project objectives have been met, including the successful customer reports. Project start to end date for retrospection. That means we should retrospect what we have done. So this is a retrospection meeting. Basically, it will be held within the team, stakeholders, any customers involved, any feedback. All this will be considered for doing the beginning to end. We will retrospect what has happened. As a part of the retrospection, we do lessons learned, best practices, and of course improvement. What we are going to improve for future such projects or products in terms of how it can be better utilized or better displayed, so that it is going to be minimized in terms of effort, or it could be cycle reduction, or it could be cost, whatever it is. So it's very important that all this will be considered for project activity. Inputs is, for doing all this we need a project document which we have done, and we are going to baseline project plan. Sorry, project plan is one of the baseline, because we have defined in the project plan saying that how I am going to close it, the project. Output of the test closure activities: project retrospection reports. There is a retrospection report which I think I will take up in future sessions, and there is a minutes of meeting. You all know that we have to record what is the minutes that is done in the meeting. That minutes will identify the discussion summary, any actions required, anything that we want to highlight. All this will be part of this outputs, and of course, as part of the output of this disclosure, we will definitely have to have a feedback or the acceptance from the user or the customer. As I said, the customer feedback is important, because that is going to feed into the next level in terms of improvement or applying to various other aspects in the organization, or it could be appreciation also, what will we have done best, so that we can use it, we can reuse it. Those parts are very important and very good also. The last one is exit. How we are going to exit this project checklist. There is a checklist that should be completed, which will be maintained in the server by the concerned people, and all the applicable activities in the checklist should be closed. There should not be any open items, so that the project is closed. And either we would have we have got the acceptance or the feedback. If not, we might seek as part of this closure. So what will happen is, sometimes the project deemed to be closed from internal perspective, where we have used the team, and the project is delivered to customer, and the customer is yet to be evaluate the product. He would have done partially, saying that in principle he will agree with the deliverable, but he would not have come back with a complete feedback. So in that case, what we will do is, we will dissolve the team, keeping one or two stakeholders till we get the complete customer feedback as a point of contact. That is why this line item is told here. Customer feedback form we should send it to customer. Project learning has been recorded with review. Project folder and project server archived. As I said in the earlier step, it's an objective. The project status changed to closed. It means the database or whatever it is will be identifying project as started, in progress, open. That means the project is open but not doing any progress, and project is stalled or halted, and closed. These are some of the project status it is called. So this should be closed. Definitely closure is the one that the team will look for. So project has to be closed in order to close this process. So that is about the test closure process of the embedded testing. So this will complete the automotive testing phases and processes. As an example, there are 5 phases. So like this, there are different phases involved for different domains. Here I have told about automotive. There is a different process that is involved. As I said, computer electronics, for example. Is an example of automotive testing phases and process. Similarly, we can apply based on the need for other domains like aerospace or telecom, etc. So one example we have gone through consumer electronics product life cycle. Okay, so we'll look into some of the embedded system terms and words. This will be growing each session, so I will keep adding so that uh, you are all aware of this, because this has to be there anytime for an embedded system tester. Test harness, test bed, test bench, automated test equipment, model based testing, test steps, driver, fault injection. Slide is last but one slide is about embedded system terms and testing words. This will keep on growing as we go through different sessions, because these words have to be there in a tester's mind, because these are some of the common words getting used always by the tester or the embedded system developer. So he needs to have an idea about these words all the time. Doesn't matter what area or what domain he's working for. Test harness, test bed, test bench, ATE, model based testing, test stubs, test driver, fault injection, MCDC, test hook, boot software, bootloader, input output, interface control document, breakpoints, simulator, emulator, trace, profile, datasheet for ARM7 microcontroller. There is a big data reference manual, so called as errata, identifying all the any issues or errors for the particular microcontroller. In circuit emulator, test equipment, code checker, static analysis, dynamic analysis, hex, disassembly, reverse engineering, life cycle, entry and exit criteria, baseline, prototyping, stakeholder. Some of this we studied today. Maybe some more words I will add it in the next session, so that you can understand or study those words in detail. So I have a question for today's session. What are the, I mean, this session includes for the previous session also. I think for the previous session only these questions are applicable. The current session I will add it in the next session. We have studied about life cycle in detail about view model and all that. So these questions are about that. What are the process elements that must exist? The next question is, what is the significance of prototyping life cycle? So why do we need a prototyping life cycle? And V model, why it is called as V model? Usually what model is typically followed for prototyping? So what model we use for doing the prototyping of the embedded system development or testing? Okay, that's all about today's session. So we will see you in the next session.